This topic we're talking about the clustering method for unknown number of clusters. That means in the previous topics, usually we have to determine the value of C, that is the number of clusters we want the data to be divided into. But what about that? We are going to let the algorithm to determine the best number of clusters we want data to be separated into. So that is the main idea of this topic. Clustering for unknown number of clusters. So we actually we have two methods. The first one, that is, we can just doing the try and error. We are going to say plot of figures. The x-axis, that is the number of clusters. We use the k-mean cluster fuzzy clustering method. For example, we try z equals 1, 2, 3, 4, 5, so on, and measure the error, measure the cost. For example, that is the JE, and then so we just plot the error, plot the cost, pick the one which give us the minimum value, and then so that would be the best choice of the number of clusters. So that is one method. Another one, that is, we are going to use some algorithm to determine the best number of clusters. In the following, I'm going to introduce this method, the leaders-follower clustering. And then so we still have two versions. The first version, that is without input and weight normalization. The next one, that is with normalization. And let's take a look at the details. So this is the pseudocode. The pseudocode, that is the one without normalization. In the beginning, I'm going to use the next slide just with some examples, and then with that example to explain that line by line. Yeah. Okay. Now, right here, this is the pseudocode. In the beginning, we are going to initialize the learning weight eta. It must be greater than 0. We have to choose the value of eta, and also we are going to choose a threshold value to determine whether we are going to create a new cluster or not. So theta, that is a value we have to pick. So pick a sample from the data set, and then so we call this is the M1. So for example, this is M1 right here, and then because when we first enter into this pseudocode, we do not have any clusters. It is different from what we have done before. We have to specify the number of clusters. So in the beginning, we do not have any clusters. Pick the first samples, randomly pick the sample from the data set, and we call this sample to be M1. And then next, in the do until loop, we are going to take another sample, a new X. So for this new X, assume that we run this algorithm for a few times. So we already have M1, M2, M3, M4. Now in this line, we are going to find the nearest clusters. That means we are going to classify this new sample X. So we are finding the distance, this distance, that is, this is the, say, X hat minus M1, X hat minus M2, M3, M4, we find out the smallest distance, that is the winner, M4. Yeah. And now J in this case, that is 4, because X hat and M4 which produce the smallest distance. Yeah. Okay. Now the next step, that is the if else loop, we are going to use the threshold. Checked whether this distance, whether it is smaller than theta or larger than theta. So it means that we are going to draw a circle right here with the radius, that is theta. So if the M4 is not within this radius, and then so maybe I consider the condition is correct. If M4 is within this circle, and then so we are going to update M4 using this update rule. That is current M plus eta times difference between X and M4, and then that is the new value of M. If this M4 that is not within is not within the circle. So we are going to create a new cluster. So in this case, we will call this point M5 and then go back to the top. Now, if we're going to check whether this condition is satisfied or not. If there's change in W, that is the centers, and then so we are going to, this one should be M instead of W. If there's no change in the cluster center, and then so we are going to stop and return all this M to be the cluster centers. Otherwise, go back to the top right here, pick another samples and repeat this process to determine which centers we are going to update or we are going to create a new centers. Okay, so this is the basic idea. Now what we are going to do next, that is to go through the second version, that is with normalization. Again, we have to do augmentation and normalization. That means before we are going to work on all the samples, we are going to add one on top of this X, and then this is the augmented version, and later on in the next slide, that is we are going to normalize that by xi divided by the L2 norm of xi. I mentioned this before in the previous section. Now, the same idea, that is the first x draw from samples. We call this is the M1, that is the first samples. Now, we are going to go to this do statement. Take another sample, randomly pick one from the data set, and then remember to do augmentation and normalization, just like what we have done before. So pick the one which give us the maximum inner product, and then that one we call the winner, that is the MJ. So this one, that is just to find out, for example, we have a new sample X hat, we have M2, M3, we are going to find out this value. M1 transpose X hat, M2 transpose X hat, M3 transpose X hat, and then pick the one which give us the maximum value. And then now we are going to use the distance again, just like what we have done in this diagram. That is to pick the one which give us to check whether the distance is smaller than theta. That is to check whether it is within the circle or not. Okay, so if the winner M that is less than theta, and then so we are going to update the MJ using this update rule, applying the learning weight right here. Remember to do the normalization after we update MJ. So if this condition, if this MJ that is larger than theta, and then so we are going to create a new cluster. Now we are going to create new clusters right here. So that is to use this new sample we draw from this point, and then to make this to be a new cluster M4. Remember to do the normalization, check whether there's any change in all these centers. If no, and then so we are going to return this M1, M2, so and so as the cluster centers. Otherwise, go back to the top, pick another samples, update or create new clusters. Okay, and now that is the conclusion. In this topic, we talk about the clustering, and we will find out that clustering, that is a very useful tool for us to extract some features from the samples without using the labeling, and then so we know the underlying features of the data, and then when we apply unsupervised learning for clustering, and then it can be done in a block. For example, in k-mean clustering, we are going to perform the update using all the information of the samples, or we can do online based. That means we draw sample one by one to update the clustering, to update the cluster centers, such as the competitive learning. And then we can also find out that there are some drawback. That is, when we use some of the clustering method, it is sensitive to the initial condition as well as the hyperparameters. For example, the number of clusters as well as the initial cluster centers. So the issue, it will need to sometimes the iterative algorithm will not converge if the hyperparameters are chosen not right. And also another issue, that is we cannot guarantee global optimal. Yeah. And also we have another issue, that is how do we measure the similarity between clusters when we group clusters in hierarchical clustering method. Different metrics will lead to different result.